Now let's have an architectural overview of a common BI solution. A common BI solution will usually have 4 layers. The first layer is your data sources, from where you will get the data that you'll store in your data warehouse. So our data sources can be either a CRM application, a billing application, an ERP application, or even flat files. We'll take all these data sources, we'll take them through what we call as ETL process. ETL stands for extract, transform, and load. So we will extract these data from our data sources. What we'll do, we'll transform those data into a standard consistent format. Let's say, for example, some of the sources will use a US dollar currency and some other sources will use Bahraini dinars currency. When we store them in our data warehouse, we should have consistency. All data should be in the same currency. Whatever is our unit that we will choose, all of our data should come in the same unit before storing them in the data warehouse. And load stands for loading the data in the warehouse. Microsoft already has a tool that will give you the ETL development toolbox, which is called Microsoft SQL Server Integration Services, SSIS. We will not be covering this tool here, but you can investigate this tool further to see what are the options that are available to load this data into the data warehouse after we build it. The data warehouse itself will contain our fact and dimension tables. And here also in this layer, we'll build our cube. After the data warehouse layer comes the visualization layer, how we're gonna give this data to our customers to analyze. It's either through reporting, analytics, or data mining. Here in this session, we'll be talking more about reporting and analytics and building the actual data warehouse and the cube. The cube, actually, it's a multi-dimensional structure of your data. So whatever you will store in your relational tables, we need to represent them in a multi-dimensional model. So for example, if we have a sales data to be represented, so we can have on one dimension the stores, the other dimension will be the months or the dates, and the third dimension will be the product. So for example, if I want to know how are my sales for product 1 in store 3 at March, I can immediately go and find what is the value that I'm looking for. It will also be easier to aggregate those values and find the averages or the sums if we have the data modeled in this way, even if we are dealing with millions and millions of rows of records. The data warehouse is usually a subject-oriented, non-volatile, and integrated, and time variant. Subject-oriented, we mean the data warehouse will usually represent one subject matter for your business. For example, the sales, or marketing, or finance. We'll build a data warehouse for sales. We'll build a data warehouse for marketing. We'll build a data warehouse for finance department to be used, because these are different subjects for your business, and usually we call each of them a data mart. Non-volatile means the data doesn't change. Once it's stored in the data warehouse, it will remain as is. We'll not be changing this data. Integrated, it means consistent, like I said before. You will be using the same units, the same format for the data coming from various sources. And finally, time variant, your data will be measured by its change over time. So time is one of the important factors of your data warehouse. Your data should be analyzable over time periods. To build a data warehouse, what's the difference between a data warehouse and the traditional relational database? A data warehouse is usually denormalized. In traditional databases, we normalize our tables before we store the data, the transactional data in them. But then to retrieve this data, we'll have to join all the tables together. And here comes the problem. Because of the number of joins that we'll be doing, retrieving the data becomes slower. So in data warehouses, usually we denormalize the database. So if we have, for example, here, we have the city and we have the customer tables. So these two tables are from a transactional system. You'll store the customer name in one table, and the city, you'll just refer to the city table through primary and foreign keys. So when you want to retrieve the final output, you'll have to join these two tables together. But in the data warehouse, what we'll do, we'll store the city along with the customer name. Thus, retrieving this data will be easier, although there will be some data redundancy, but this will not be the issue here. The issue that we are trying to solve is the performance. How fast can we retrieve this data? That's why we need our tables to be denormalized. In data warehouses, usually we have two schemas to follow. We have the star schema on the left, and we have the Snowflake schema on the right. When to choose the star schema and when to choose the Snowflake schema, it's up to you and what kind of requirements comes from your business. Usually we go for star schema if we are looking for performance, if we are looking for simpler queries, and we go for Snowflake schema if we are looking for easier data management and data integrity. One other thing is with Snowflake models, dimension analysis is easier than the star schema. For example, if I want to know how many bank accounts are open for a given customer, in a star schema, we'll have the customer as one dimension and the account as another dimension, just for an example. So we will not be able to find relationships between these two dimensions. But in Snowflake schema, we can store the customer details along with the account in a normalized manner for the dimension only. For the measures table or the fact table, it will be denormalized, but the dimensions will be normalized. So it's easier to analyze the dimension itself. Here we can see how can we convert a transactional database model into a data warehouse. If we take this example, this is for a sales transactional system. We have the orders table that will contain the order details, and inside each order detail I have the product, and for the product I'll have a different table for the category. The customer will be linked to the person table, and the person table will be linked to the order table. So as you can see, this is a normalized database. So for example here, in the order details, we have the quantity, we can have also the amount, we can have the cost. We'll take these measurable or quantifiable attributes of this table, and we'll call them measures. Measures, usually we'll store them in one table in our data warehouse, which we'll call the fact table. The fact table usually is quantifiable data or quantifiable measures. For example, we have the count, the quantity, the cost, the price, or even the total. All these quantifiable data will be stored in one table, which we'll call the fact table. About the dimensions, how can we know which tables will go as dimensions? Usually the dimensions are filterable and groupable. And usually they will tell a story about the fact that we are storing in the fact table. For example, if I bought something, if I bought a car, you might come and ask me, what did you buy? When did you buy it? Where did you buy it? And who sold it to you? All these questions, the answers to these questions will go as dimensions, while the fact table will hold the measures, the amount, the real amount that I paid for this item. So the dimensions will tell a story about the fact table. And the fact table will have the measures that we can measure, the amount, the quantities, and so on. This is another example of a data warehouse and cube architecture. From the data warehouse, we'll build our cube for a sales database as well. And we'll have the dimensions of the sales database as stores, salesperson, product, customer, time, and so on. So the sales amount, cost, and quantities will be stored in the fact table, while the store, from where I bought it, or who sold it to me, the sold person, or what exactly I bought, the product, all of these will be stored in the dimension tables. After that, we can analyze our reports through SSRS report, SQL Server Reporting Services. We can use Excel pivoting to represent our data. We can use report models for ad hoc reports that will give to our user groups, operators, administrators, business executives, managers to use to analyze all the data available.